Good evening all. My name is Prasad. So subject is compiler design. So, in this subject, these are the topics, basics of a compiler. In this, we will see what is language translator, what are the different types of language translators, and what is language processing system. And we will have a brief discussion about phases of compiler. Then we will do some objective questions. After that, we will go for lexical analysis. It is the first phase of the compiler. Then syntax analysis. It is a major topic. So almost 50 to 60% of the time will be allocated to syntax analysis, because all the parsing techniques will be come in this syntax analysis topic. And then we go for syntax directed translation, intermediate code generation, code optimization, and finally runtime environment. Okay, and the standard textbook is Compilers, Principles, Techniques and Tools by Aho and Ullman, Alfred V. Howe and Jeffrey D. Ullman. And in GATE examination, from this subject, minimum you will get 4 and maximum you will get 9. It depends. You cannot say how many marks exactly you will get. So before last year, we have 2 sets. In one set they gave 7 marks, in another set for 9 marks they gave. And this year 4 marks only from this subject. So it varies. Next for you in 2023 they may give you for 6 or 7 or 8 marks. And among these, I don't say any particularly which one is more important, which one is less important, but mainly these are very important. These one second. Syntax analysis, syntax directed translation, and intermediate code generation. These are very important. Of course, every topic is important. You need not to ignore any particular topic. If you want to get a good rank, you have to aim all the topics. Okay, so every topic I'll explain, and every topic, and we do the questions, we do the objective questions. Once we complete the topic, and we'll go for the workbook solutions, and preferably I'll go for workbook and recorded version I'll give you. And if you have any doubts, you can ask me in the class. Okay, shall we start? So take this one. Okay, if any new student is here, if any one is sitting for first time for this class, and if you have not attended for TOC, no problem. So only one topic is required, that is grammar topic. I will tell you what is grammar. Whatever the knowledge required for this subject, I will go through that. Okay, you don't worry. So everything, just I will explain this subject as you don't know anything from this. Okay, don't worry, I will take care of that one. So Abhishek, I didn't say anything about, just I explained what are the topics till now. So TOC is not required, not required. Okay, so whatever the concept required from TOC, that is grammar topic, that grammar topic I will take care whenever it is required. Okay, sit happily, cool, I will take care of it. Okay. The first topic we will go for basics of a compiler. Basics of a compiler, the first topic. Language translator. Language translator. The name itself can give you the meaning of this language translator. Language translator means which translates one language into another language. Why do we require the language translator? Okay, so if you take the computer as a programmer, C language or Java language, any language, all those languages are human understandable language. Whatever you write the program, you write the program in your understandable language. There are high level languages. Suppose you are writing a C program, so you write int x comma y. As a programmer, you will understand that what is the meaning of the statement. So x and y are the two variables of integer data type. But the computer cannot understand what is the meaning of this one. The computer can understand only its own language. That is machine language. That is in terms of zeros and ones. For us, it is impossible to write the program in terms of zeros and ones. We write our understandable language. The computer understands its own language. So in between, a mediator is required. That mediator is language translator. So it takes one language as input. It takes one language as input It takes one, this is language translator. It takes one language as input, that is source code, and produces another language as output, that we call it as target code. It takes one language as input and produces another language as output. Generally, this source code will be high level language, and this target code will be low level language, high level language and low level language. So initially, the first 3-4 hours, you may feel bored because it is completely theoretical class, and the questions will come from this theory. Okay, whatever I am going to explain here, those you may get the questions in the gate exam from this theory. Okay, but once I come to lexical analysis, the speed will be goes and you will get more interesting, and syntax analysis onwards you will be involved completely, and the subject will be very good. Okay, so initially just bear me for 3 to 4 hours. So this is language translator, the language translator which takes one language as input and produces another language as output. In general, it takes the high level language as input and produces low level language as output. So you just take this one. Now there are different types of language translators. So what are the types of language translator? I will tell you, just note it down. Okay, Sandeep Pal, dictate notes please. Okay, take language translator. It takes one language as input It takes one language as input and produces another language as output. Another language as output. Then copy this part. So whoever joined for the first time today's class, so all the subject will be done to you. So today I'm taking comparison. Once I complete the comparison, next another subject. So once all the subjects are finished, whatever the subject already done, they comes in the next cycle. Example, till yesterday you had TOC. So first all the subject will be finished. So once all the subjects are finished, then the cycle will be repeated. Whatever the earlier subjects completed, like I think already DBMS and TOC and CN, these topics are done, they will be repeated. So this subject, so whoever joined today, so repeatedly don't ask this question, whoever joined today, for you, so first whatever you are already TOC is completed, so let the first cycle will be completed, CD, then another subject, then another subject. After that, whatever the subject you missed, like till yesterday it was TOC, and before it was DBMS, like that, CN. So all the subject will be covered to you. Don't worry, each and every subject will be taught to you. Okay. Now, types of language translator. Compiler, interpreter, assembler. Types of language translator: compiler, interpreter, assembler. Okay, we will see one by one. Compiler. Okay. Compiler takes the source code as input and produces the target code as output. I repeat, compiler takes the source code as input and produces the target code as output. If this target code is an executable code, then it will be called by the user to process the inputs for producing the output. Okay. So here what is this input and this is input? What is the output and what is the output? Suppose you wrote some program, C program, for multiplication of two numbers. Okay, first you complete the program, and once you execute it, once you compile it, if there are no errors, so finally you will get the executable code. That executable code is the target code. For that executable code, you are giving the inputs. So the program, whatever the source program you wrote, that is the input for the compiler. That output is the executable code. For that executable code, you are giving the input. Say 2 and 3 are the inputs, then output will be 6. Okay. So what happens? Do you understand what is the difference between this input and this input and output and output? So source program, once you compile, you get the executable code. For that executable code, you are giving the inputs and it gives the output. So what happens in the case of suppose I wrote a program. Of 1000 lines. Say line 1, line 2, line 3, so on. 1000 lines I wrote a program, or 10,000 lines, whatever. So let it be 10,000 lines. I wrote a program of 10,000 lines. When you execute the program, the compiler executes this total program from top to down at a time. That means even though any errors present in the program at any line, the compiler won't stop. If you write a program of say 1000 lines only, suppose you wrote a program of 1000 lines, the compiler executes from top to down, top to bottom, all the lines without halting. That means even though errors are there at line 4, the compiler won't stop. It executes line 4, line 5, line 6, all the 1000 lines. After that, out of these 1000 lines, if any errors are there, all those errors will be given to the user. Suppose out of these 1000 lines, if you have 250 of errors, so and so error at line 5, so and so error at line 10, line 14, line 20, like that, you have 250 of errors out of these 1000 lines. All those 250 errors will be produced or given to the user. So once you see 250 of errors on the screen, so error diagnosm in using compiler is not that much easy. So psychological some feeling will be there. So out of 1000 lines, if you have 250 of errors on the screen, on the monitor, so how you feel? So error diagnosm in compiler, comparatively the other one, interpreter, is not that much easy. I'll tell you what is interpreter later. So here, in the case of compiler, it executes the total code at a time, and if any errors are present, all of them will be given. So definitely you have to resolve them one by one. So you resolve one first error, second error, so on, all the errors. So again you compile it. Whenever you compile it, every time the compiler executes the total code from top to bottom. Every time it executes the total code from top to bottom again and again. So now this time you got 100 errors. You got 100 errors. All those 100 errors will be given again. Again we resolve one by one. And after that you got 50 errors. After that you got 50 errors. Again you resolve them. So finally you got the successful code. You got the successful code. For that successful code, once you give the input, immediately it produces the output. Again a different input, again different output. So once you get the executable code, then output generation by compiler is faster when compared to other one, that is interpreter. Okay, now I repeat. So the compiler executes the code from top to bottom at a time. If any errors are present, all of them will be given at a time. And error diagnosm by compiler is not as easy in the case of interpreter, but output generation by compiler is faster. So here the compiler won't execute the program directly. It won't execute the program directly. It gives the executable code. So that object code, the target code. This target code you have to store in the main memory. So that is the reason compiler takes more memory when compared to interpreter. This point you just hold on. This point you will understand more easily when I come to the interpreter. Okay, now the compiler, the example for compiler is C, C++, and like C#. Okay, Java is both compiler and interpreter. So you can take this. Okay, first take this one. I'll give you some notes. Somebody is asking the notes. Output generation by compiler is faster. Output generation by compiler is faster. Why? Because once you get the target code, for the target code you pass the inputs, immediately it gives the output. So you just hold on. Once I complete the interpreter, you will understand the difference between this compiler and interpreter. Okay, so take compiler. Take compiler. Compiler takes the source code as input. Compiler takes the source code as input and produces the target code Compiler takes the source code as input and produces the target code as output. Produces the target code as output. If this target code is an executable code, I repeat, compiler takes the source code as input and produces the target code as output. Okay, so make it fast. If this target code is an executable code, so initially it requires some time to sync between you and me. So if you have any doubts and if you want to repeat, so you can go, you have the access to repeat, to view the video. I think you can watch the video. So you go through with it through the videos. Once after 1 or 2 classes, definitely there will be a good, better sync between you and me. Okay. So if this target code is an executable code, then it will be called by the user. It will be called by the user to process the inputs. For producing the output. Okay. Next point. Compiler execute the entire code. At a time. Continue. If any error occurs at any line, I repeat, if any error occurs at any line, all of them will be given at a time. If any error occurs at any line, all of them will be given at a time. comparatively error diagnosm, diagnosm, comparatively error diagnosm. So this is the subject and these are the topics. My name is Prasad. So somebody is asking my contact number, later I will give you. As of now it is not required. And one more thing, many of you already know my number, and so already one group is created earlier by other faculty, Ravi sir. Okay, so please concentrate on this subject. So I follow my style. So don't worry, somebody is asking not to repeat, and somebody is asking not to dictate, somebody is asking to dictate, somebody asking to repeat. So just hold on. So initially today is the first class, so that is the reason I may going slow. So after 1 or 2 classes, definitely everything will go well. Okay, now, so comparatively error diagnosm in compiler is difficult, but output generation by compiler is faster. Output generation by compiler is faster. Okay, next. Compiler takes the more memory. Compiler takes the more memory as object code has to be stored. Compiler takes the more memory as object code also has to be stored in the main memory. Okay, so I'll explain this point one more time once we complete the interpreter. So take the example C, C++ and C#. So this is the diagram. If you just copy this one, then I'll go for interpreter. Done? Okay. Next. So in this topic, we will see first what are the different types of language translators. One is compiler, interpreter, and then assembler. After that, I will explain what is language processing system. Means once you write the program, what happens till the execution of the program. Then we will go for the phases of compiler briefly. Okay, that is will be covered in the first topic. Then the first topic and the next topic, the second topic is lexical analysis. Okay, next, interpreter. Okay, look at this. The interpreter takes the source code as input, and it executes the code directly. It won't give any intermediate language. So what is the case of in the case of compiler? Compiler takes the source code as input and it produces intermediate language. For that intermediate language, we pass the input, then it will produce the output. Whereas in the case of interpreter, it takes the source code as input and executes directly. It won't produce any intermediate language. Okay. So I repeat, in the case of interpreter, in the source program itself, we pass the inputs. And it executes directly. It gives the direct output. What happens in the case of interpreter? Suppose we wrote a program of 1000 lines. Say this is line 1, line 2, line 3, line 4, so on, and 1000. The interpreter executes the program. Line by line. Of course, compiler also executes line by line, but even though in the case of compiler, even though there are errors at any line, the compiler won't stop. It executes from top to bottom, all the lines. And out of them, if any errors are present, all of them will be given, so and so error at line and line column numbers, like that. If any error at line 5, at any column number, so that error will be produced. All like that, all the errors will be produced. Whereas in the case of interpreter, the interpreter executes the line by line. That means it executes first line. If no error, then it executes second line. If no error, then it executes third line. If any error present at line 3, then the interpreter immediately stops. An exception has occurred. An error has occurred. That error immediately will be produced. To the user. So and so error at line 3. Do you understand? So that error only will be given to the user. So user psychologically feels happy. Oh, I have got only one error. So easily he can diagnose that error. Until the user resolves the error at line 3, the interpreter will not move to the next line. Do you understand? So compiler and interpreter execute the code in the sequence only. Even though error occurs at any line, in the case of compiler, the compiler won't stop. It executes all total program and finally it will produce all of them. Whereas in the case of interpreter, it executes line by line. If any error present at any line, immediately that error will be produced. So error diagnosis can be easily done by the user, because he will get only one error at one line. So until you resolve the error at a line. Suppose we got the error at line 3. Until we resolve the error, until we fix that error, the interpreter will not move to the next line. Once the error is resolved, then it will go to the line 4, then line 5, then line 6. Again, if any error at present and any line, immediately it will be produced. Do you understand? So error diagnosis in interpreter is easy than the compiler. Got it? And once it completes the last line, the 1000 line, immediately it will produce the output. Okay? In the case of interpreter, no question of intermediate language. In the program itself, we pass the inputs. If you change the inputs, then the interpreter again executes from top to bottom. So that is the reason the output by interpreter is slower than the compiler. Whereas in the case of compiler, once you get the target code or object code, for that object code we pass, as long as you pass the inputs, immediately it produces the output. Whenever you are giving to input to this object code, the compiler won't execute this code again and again. We have the executable code. For that executable code, we pass the input and immediately output. You change the input, different output. Whereas in the case of interpreter, if you change the input, the interpreter executes the code again and again. You change the input, it executes. Again you change the input, it executes total. So that's the reason every time of execution of the total program, the interpreter takes more time than the compiler. And once here the interpreter, we can say it is online process. We can say it is online process. It executes the statement 1, the line 1. If no error, line 2. So simultaneously it will take the inputs. So any necessary action is required. Okay, it processes the inputs according to the statement. Suppose it executing the second line. If any necessary process is required on the input, it will take that action and then it will go to the line 3. So it takes the input simultaneously. That is the reason we can say interpreter is online process. Once it executes line 2, it need not to store anywhere this. Then it comes to line 3, then line 4, then line 5, and finally after 1000 line it will produce the direct output. So you need not to store this intermediate code or object code anywhere in the main memory. So that is the reason interpreter requires less memory. Whereas in the case of compiler, you have to store the object code in the main memory. So compiler needs more memory. And it is offline process. It is offline process. Once you get the object code, for that object code we are passing the inputs. So it is offline process. Whereas in the case of interpreter, so it executes the statement and also it considers the inputs and it processes the input simultaneously if any requirement is there. That is the reason interpreter is online process. Got it? Next, and suppose you have developed a program using the compiler, and to the end user you need not to supply the source program. Suppose you have written a program using the compiler. So you just give the exe file, executive file, to the end user. So the end user use that executive file. So it is difficult to do any modification in the source program to the end user in the case of compilation. In the case of interpretation, if you are giving this program to the end user, you have to supply the source code, entire source code to the end user. So the end user can easily do the modifications in the source program. Do you understand the difference? In the case of compilation, you just pass the exe file to the end user. In the case of interpreter, you have to give the entire sourse code. So the end user can do the changes in the source program easily. And interpreter takes less memory because you need not to store the object file anywhere. Whereas compiler takes the more memory because object file also has to be stored. And compile is faster because once you get the executable code, for that executable code, as long as you give the inputs, it produces the output. And in the case of interpreter, if you change the input, the interpreter executes the total source code. That is the reason every time you change the input, it executes the code. That is the reason interpreter is slower than the compiler. And here the easy thing is the error diagnosm can be done easily in the case of interpreter. An example for interpreter: Lisp, Python, Perl, Ruby, MATLAB. Okay, so I'll dictate this one, you can copy. So take interpreter. Interpreter takes the source code as input, and produces the direct output. It will not produce any intermediate language. as in the case of compiler, the interpreter takes the source code as input and produces direct output. It will not produce any intermediate language as in the case of compiler. Okay. Next, interpreter execute the code line by line. Interpreter execute the code line by line. If any error occurs at any line, immediately that error will be produced. I repeat, interpreter execute the code line by line. If any error occurs at any line, immediately that error will be produced. Full stop. Continue. Until we resolve that error, the interpreter will not move to the next line. Okay. Next point. Error diagnosis in interpreter is easy. But output generation by interpreter is slower. Next point. Interpreter takes less memory as it is online process. Okay. So if any error occurs at any line, the interpreter will produce that error immediately. Until we resolve that error, the interpreter will not move to the next line. Next, the error diagnosis in interpreter is easy, but output generation by interpreter is slower than the compiler. Next one. So interpreter takes less memory as it is online process, because we don't produce any object code, it don't produce any target code, it produces direct output. So we need not to store the object code anywhere. Whereas compiler, you have to store the object code. That is the reason compiler takes more memory and it is offline process. Interpreter is online process. Okay. So take example. Take this one. And examples: Lisp, Python, Perl, Ruby, MATLAB, and also PHP. So take all this. Then we will go for assembler. Okay. Tomorrow is 9 to 6. Tomorrow the timings are 9 to 6. Okay. Every Saturday, Sunday, 9 to 6, and the weekdays 6 to 10. Okay. Now the third one, assembler. So assembler is also a language translator. Actually, what is language translator? It takes one language as input and produce another language as output. So it takes assembly language code, It takes assembly language code, or you can say target code, okay, as input and produces relocatable machine code as output. This relocatable machine code has to be stored in the main memory, which is ready for execution. Okay, actually compiler produces the target code. This target code is nothing but assembly language code. This assembly language code is not completely low level language. It is not a machine code. It is some intermediate language. It is some mnemonic version of machine code. Okay, I repeat, compiler takes the source code, it produces the target code. Target code is nothing but here assembly language code. Assembly language code is not a complete low level language. It is not a machine code. It is some mnemonic version of machine code. It is some intermediate language. It is some intermediate language. That intermediate language we are taking as assembly language. That assembly language will be given as input to the assembler. So assembly language uses opcode for instructions. Opcode is basically gives information about the particular instruction. Okay, and symbolic representation of opcode is called as mnemonics. Example, I am writing. So I think every one of you have some experience with the 8085. Add A comma B, add A comma B. So here add is a mnemonic. And A and B are the operands. Okay. So assembly language uses opcode for the instructions. Opcode gives you the basic information about each instruction. Okay, the symbolic representation of opcode is called as mnemonics. Like add is a mnemonic, and suppose you multiply and division and subtract, and A and B are the operands. So here assembler, so basically you can call assembler as a compiler. Assembler is also compiler. What is compiler? A language translator. Assembler is a compiler of assembly language. Assembler is also, you can call it as a compiler of assembly language. What is compiler? It takes one language and produces another language. So here it takes assembly language and produces the machine code, relocatable machine code as output. So assembler is nothing but compiler of assembly language. Okay. So here assembler also, assembler we can define as a two types based on the phases. So it can be one pass assembler and multi-pass assembler, multi-pass or two pass assembler. The types of assemblers: one pass assembler and two pass assembler. One pass assembler, nothing but whole will be done in one go. Means it takes the assembly language and convert into machine code. That is one pass assembler. What is two pass assembler or multi pass assembler? First it processes the assembly language and it creates the opcode table and symbol table. It defines the opcode table and symbol table. What is symbol table? Symbol table is a data structure which contains the information about the variables and their attributes. Okay, what is opcode table? Opcode table will contain the mnemonics and their corresponding values. So in first step, in the case of I repeat, one pass assembler, it is an assembler which takes the assembly languages and convert the direct machine code in one step. Coming to the multi-pass assembler or two-pass assembler, it will be done in two steps. First one and second one. In first one, it creates the opcode table and symbol table. And also it keeps record of location counter. And then based on these values, it creates the machine code. It converts the machine code. What is opcode table? It contains the information about the mnemonics and their corresponding values. Symbol table means it contains the information about the variables and their attributes. Okay, based on these values, it converts the assembly language into machine code. This is in first step and second step. It is called two-pass assembler or multi-pass assembler. And assembler is a platform dependent. Platform dependent. That means whatever the assembler you have developed, that works for that particular platform only. If you change the platform, you have to design the new assembler. So actually it is a huge topic about this one, linking, loading, assembler, interpreter, all this, but whatever we required, that only I am giving you. So I need not to waste your time. So whatever required, that is enough. Okay, so coming to the assembler, it is a language translator which takes the assembly language as input and produce the relocatable machine code as output. This is the code which is ready to execution, which is ready for execution, and this has to be loaded whenever you execute any program. So until execution, at the time of compilation, at the time of assembling, at the time of linking, so everything until that it will be stored in the secondary memory, that is disk. But at the time of execution, you have to bring that program into main memory. Okay, so now here, so what is assembler? It is this one. It takes the assembly language and relocatable machine code. Then so what is different types of assembler? One pass assembler and multi-pass assembler. Okay, these are two types, and it is this is enough. You don't require more than this one. Okay, I'll give you the notes for this. You just copy. Take assembler. It takes assembly language code, takes assembly language, that depends on Aniket Rathore, mnemonics do jump and move in assembly language. So depends, jump means jump, otherwise add. So they are the instructions. Take assembler takes the assembly language code as input, takes assembly language code as input, takes the assembly language code as input and produces relocatable machine code as output. Which is ready for execution. Take assembly language is not a complete low level language. Assembly language is not a complete low level language. It is an intermediate language. That is some mnemonic mnemonic version of machine code. Next. Assembler is platform dependent. Okay, next, continue. Assembly language uses opcode, opcode. Assembly language uses opcode for the instructions. Assembly language uses opcode for the instructions. Continue. An opcode basically gives the information about the particular instruction. Opcode gives information about the particular instruction. Continue. So please concentrate on this. So the rest of the things we can discuss at the end. Okay. Next. Continue. The symbolic representation of the opcode is called, I repeat, assembly language uses opcode for the instructions. An opcode basically gives the information about the particular instruction. The symbolic representation of the opcode is called mnemonics. The symbolic representation of the opcode is called mnemonics. Okay, so you can take example. Add A comma B. Add is a mnemonic. A comma B are the operands like division, subtract. Next. Types of assembler. Based on the phases, PHASES, based on the number of pages, I repeat, based on the number of phases used to convert to machine code, it is of two types. First one, one pass assembler. Takes the definition. One pass assembler takes here. This assembler, one pass assembler. Take this assembler. This assembler performs the whole conversion. Of assembly code to machine code in one go. Go. I repeat, one pass assembler. This assembler performs the whole conversion of assembly code to machine code in one go. Second one. Okay. Next, multi-pass or two-pass assembler. Multi-pass or two-pass assembler. Take these assemblers. First, first process the assembly code. And store the values in the opcode table and symbol table. I repeat, these assemblers first process the assembly code and store the values in the opcode table and symbol table. Full stop. And then, I repeat, these assemblers first process the assembly code and store the values in the opcode table and symbol table. Okay, and then in the second step they generate the machine code using these tables Okay, take first one, opcode table. Somebody asked me opcode table. Take the opcode table, OPCODE, opcode table. Take this stores the Okay, I'll go slow. See, in dictation you must be fast. Otherwise, I don't dictate, you can take the running notes. Okay, anyway, so this is the initial class. So slowly you will be habituated to my style of teaching. Okay, definitely I'll go slow. Okay, take opcode table. This stores the this stores the pneumatics mnemonics and their corresponding numeric values Next, symbol table. Guys, symbol table we will discuss more in future. Even though, just take a little bit. Symbol table. It stores the variables and their attributes. Simple. Okay. We will discuss more about symbol table in the later cases. Okay. Guys, this is so about assembler. So take this one, and example for assembler is GAS gas and GNU. They are the examples of assembler. General Assembly and GNU, they are examples for assembler. And I think I have dictated that assembler is a platform dependent. Okay, so copy. So these are about this is about language translators: compiler, interpreter and assembler. Next one is language processing system. Done. So every day from Monday to Friday our class is from 6 to 10. So in between we will take 10 to 15 minutes break, and Saturday, Sunday 9 to 6. Okay, in between we will take 1 hour lunch. So I am very friendly. So whatever you say I follow. Okay, don't think that I don't listen you. But tomorrow somebody already asked me to change the timing. Sorry, actually it is already decided. So those who cannot attend, somebody has texted me that he has some exam. So you please go to the recorded version. And sorry, tomorrow 9 to 6 is the timing, and every Saturday, Sunday 9 to 6. As today is the first class, that is the reason we have arranged from 6 to 10. Okay. Just copy this one, keep copying. Link editor, or you can call it as linker or link editor, both are same. This is loader. So preprocessor, compiler, assembler, linker or link editor, and loader. Source code is given to preprocessor. This is high level language. And it gives the output as modified source code as output. It is pure high level language. Okay. Then compiler takes the source code as input and produces the target code, or you can call it as a assembly language code. So keep copying. Okay. Next, assembler produces relocatable machine code as output. And this relocatable machine code as given as input to the link editor, and link editor produces the executable code as output. And the loader finally execute that code and makes it ready for execution. Okay. So copy this one. I'll make it on modest. Okay. So just copy. I'll explain clearly about everything. Already we have done about compiler and assembler. So mainly I concentrate on pre-processing and linking and loading. Okay, copy. Okay, some of your doubts get cleared in future, means at a time I cannot clear all your doubts. Some of you are asking the doubts which I teach in the next topics. Okay, and moreover, every Saturday Sunday the timings are from 9 to 6, and in between we have 1 hour of lunch. That depends. If you need only half an hour, I will give half an hour. Otherwise, maximum 1 hour. So these timings and our breaks and we can change. It's not fixed. So if I take 9 to 6 means, so the lunch time it varies. Generally 1 to 2. Otherwise, if I finish earlier, I may give early a break. So these all okay, small things. Okay, copied. Then this one, relocatable machine code, executable code and execution. Make it fast. Please, you concentrate on the present topic only. You don't think about the WhatsApp groups and WhatsApp numbers and my name, my place, and all these are not necessary. So slowly you will know everything. So CD will be completed by around May 6th or 7th. That time I will complete. Okay, and workbook I will give you the recorded version. So definitely after every actually the workbook, the first chapter is based on the basics of compiler and the lexic analysis. Based on the two topics, the first chapter is given in the workbook, and then the second chapter is based on syntax analysis and syntax directed translation. Based on the two topics, second chapter is given. But once I complete the syntax analysis topic, I will provide you the workbook solution of all the syntax analysis questions. Actually, there are almost 100 plus questions are there. Out of those 100, whatever the questions are given based on the syntax analysis, so for those I will give you the workbook solutions. Then again we'll go to the next topic, syntax directed translation, and whatever the remaining question left, for those also I'll give you the recorded. So clearly I'll give you the recorded solution, and don't worry, I'll give you the times. Today we are doing the basics of compiler. Tomorrow lexical analysis will be completed. So by tomorrow we will complete both the first two topics, and I hope tomorrow I'll start the third topic, syntax analysis also. I'll go to the topics, because these are the general doubts. You just leave all these. I will take care of everything. Okay, just believe me and concentrate on whatever I am giving you. So at the end you will know everything. Just believe me. Slowly just you concentrate and try to understand my communication. If you have any problem in communication and language pronunciation, you just concentrate on that. You can suggest me. I can change until you understand. But dictation is little bit faster, so I will dictate it slowly. Okay, so the remaining topics and concepts, you just leave it to me. That is my headache. I will take care of everything. These are the topics. Okay, and the workbook is given. This is the first chapter. And second chapter, this is the second chapter, and this is the third one, and this is the fourth one. These are the workbook chapters. So after completion of this one, I'll give you the solution of first one, recorded version, and definitely I'll give you the time. So you do, first of all, you do whatever I teach here. Based on that, you try the workbook. Then only you go to the workbook solutions. Of course, tomorrow I don't upload the workbook solutions. Day after tomorrow only I will upload the workbook solution of the first two chapters. So by this time you do your own. Okay, then you just verify the that video. In that, if you have any doubts, definitely I will listen every one of you. If you have any more doubts or any more clarification, definitely I do in the live class. Okay. And coming to the second chapter in the workbook, it is given based on the 3 and 4 mixed. So whatever the questions from the syntax analysis, I will do it as a one separate video, and then syntax SDT, whatever the questions given as based on SDT, I will do it as a separate video. So after completion of every topic, the video will be uploaded, and I'll give you 1 day of time to do your own. Okay. And if you have any doubts on the workbook or any questions, we will do plenty of the questions. If you have any doubts on the workbook solutions also, you can ask me in the class. So these things I will take care of it. Initially, just concentrate on the subject. Whatever the topics I am going to see, it is not completed. It is just first day, and even we have not done anything till now. Almost it is 1.5 hours. But in this 1.5 hours, I have not done anything. Just I told you what is language translator, interpreter, compiler, assembler. Other than this, I have not done anything. So slowly we will go into the deep, and I promise you, every one of you will understand everything. And I will be available 24 hours. You can ask me any doubt, anytime through WhatsApp. My name is Prasad. I'll give you my number after some time. Okay. So these things you don't concentrate. Leave it to me. I will take care of it. Okay. And this intermediate code generation, third one, and last runtime environment. So I will be available until you come from your GATE examination 2023. After that also, we will give you the live solutions after those 23 questions, GATE 2023. So don't worry, boss. Okay. Okay, now come to this one. I think you have copied all this. Okay, I have given you enough time. Now, preprocessor. It takes the source code as input and produces the modified source code as output. That you can understand by looking at this. Okay. So whatever the commands used in preprocessing are called as preprocessor directives. They begin with the symbol hash. Okay. It takes the source code as input and produces modified source code as output. Okay. Suppose if the program is very big, it may be divided into small programs. And each small program we call it as modules. If the program is very big, it may be divided into small programs, and each small program we call it as a module, and each module will be stored in separate files. Say this is in file 1, this is in file 1, this is in file 2, this is in file 3, like this. The preprocessor will take care of all these modules. Don't misunderstand that. The preprocessor will link all the modules. No. The linking will be done by linker. Linker tells you that it links. Okay, the name itself gives you the meaning. So if the program is very big, if they are divided into small programs, each small program we call it as a module, and each module will be stored in different files. The preprocessor will take care of all these modules, which module in which file. Okay. Now, whatever the commands we use in preprocessing, they are called as preprocessor directives. They begin with they begin with hash symbol. They begin with hash symbol. Okay. Now, the some list of preprocessor directives are hash include, hash define, some list of preprocessor directives. Hash include, hash define, hash if define, hash if n define, means if n def, hash if, hash else, yes elif like else if, hash and if, this is for if and end of if condition. Okay. Then hash error, hash undefined. I'll tell you what are all these. Hash pragma. These are some list of preprocessor directives. Okay. Now, I repeat, whatever the state commands we use in pre-processing, they are called as preprocessor directives. They begin with hash symbol, hash include. This is used for file inclusion. This is for, now what is the meaning? So this is file inclusion. File inclusion. Syntax for this: hash include some file name. Example: hash include stdio.h, standard input output.h, like this. So what happens? So the preprocessor removes all hash include directives, all hash include directives by placing wherever it is located, in that it will place the code for whatever the code available at this. Actually, these are all available in library, built-in library. So whatever the code exists for this, so the preprocessor will remove this all hash include statements. The preprocessor will remove all hash include statements by placing wherever it is defined. So whatever the code exists in the library, that code will be placed here by removing this all hash include statements. This is called file inclusion, and syntax for this: hash include file name. Okay, I repeat, the pre-processing will be done before compilation. Whatever the hash include statements are there in the program, all those will be removed. In that place, whatever the code exists in the library for that file name, that will be placed in the program at specified location. This is called as file inclusion. So this is about hash include. Okay. Next, hash define. This is used for defining a macro. What is a macro? Suppose in the program you are using some instruction. These are some instructions. Okay. Now, and this is the program, remaining program. After some lines of the program, again we are using same set of instructions. Whatever we have done, here also we are doing. Again, after some set of instructions, same set of instructions we are using. So if you are repeatedly used the same set of instructions, if you are writing the same set of instructions repeatedly in the program, of course we can define it as a function. Then what is the difference between function and macro, we will see later. Okay, now we are concentrating on macro. If same set of instructions we are repeatedly, if you are using repeatedly in the program, I repeat, if the same set of instructions if you are writing repeatedly in the program, then those set of instructions we can define as a macro, and we give some macro name. We give some macro name. And wherever these set of instructions are repeated, so instead of writing the same set of instructions, we call it with macro name. I repeat this one. If you are using some set of instructions repeatedly in the program, so we define those set of instructions macro, and we give some macro name whenever they are called or wherever they are required, we call it with macro name. Okay, so before compilation, these macro, wherever you are using, these will be expanded before compilation. So whatever you are calling with this macro name, these will be expanded before compilation. That will be done by macro processor. I repeat, if you are repeatedly used the same set of instructions in the program, we define them as a macro. We give that one name. We give some name to that macro name. Wherever those set of instructions are required, we will call those instructions by its name. And before compilation, these macro names are expanded. That the macro expansion will be done by macro processor. Okay, there are two types of macros. One is object-like macro, and another one is function-like macro. Two types of macros: object-like macro, function-like macro. What is object-like macro? Suppose hash define A10. So in the program, after this, wherever A is there, so before compilation, wherever you are using A, that will be replaced, A will be replaced with 10 value. Are you following? So before compilation, this macro expansion will be done. Wherever you see, hash define A is 10. So see, suppose before this, if you are using A value, before this definition, definition of macro, if you are using A, that A won't be replaced with 10. Wherever you have defined, after that, wherever A is there, that A will be replaced with the value 10, but not before this. Do you understand? This will be done before the compilation. Now, suppose hash undefine A. Okay, that means after this, wherever A is there, it won't be replaced with 10, because we have defined A here and we are undefined. Hash undefined, these are the, see, hash undefined. This is hash defined is used for defining a macro. Hash define is used for defining a macro. Hash undefining or UNDF, hash undefined, is used for undefining a defined macro. Okay, I repeat. Yeah, see, 1 second. Look at this. I have defined A10. So after this, wherever A is there, so macro processor will replace A with value 10. Okay, and after some instructions, I have undefined A. That means this, after this line, wherever A is there, A will be A only. It won't replace, or it won't replace A with 10. Okay, and suppose here hash define A20. Then after this, wherever A is there, so macro processor will replace with A with 20, whereas here A will be replaced with 10. So that is the meaning of undefined. If I don't write this undefined A, then Do you understand? So undefined is used for undefining a defined macro, and this is object like macro. And what is function like macro? What is function like macro? This is the definition. This is example for object like macro. Okay, now function like macro hash define add. Suppose add is a comma b, a plus b. That's it. So whenever I am calling add, suppose if this is the definition, invocation of this macro, this is the definition of macro, add a comma b and a plus b, and this is invocation. This is the definition and this is invocation, add 2 comma 3. Then what is the result of macro expansion? The result of macro expansion will be 5, and this is the invocation of the macro, okay, and this is the definition. This is function like macro, and this is object like macro. This all will be executed, but not executed, this will be processed before the compilation. Okay, that is done by macro processor. And what is the difference between macro and function? Macro will be done before compilation, whereas function will be done at the time of compilation. And macro cannot check the type checking. Using macro, type checking cannot be done, but using function, type checking can be done. And generally macro will be used for small set of instructions. Macro will be good and well suitable for small set of instructions. If set of instructions are very big, then function will be used. So macro will be used for small set of instructions, whereas function will be used for large set of instructions. And compile time error cannot be checked using macros, and function can check compile time error. And using macro, it is a faster. And function is a slower. Okay, these are some differences between functions and macro. So simply before compilation, macro will be expanded, and before compilation, a macro name will be replaced by its value, and whereas function, during the function call, a transfer of control takes place. I will give you all the differences later, just you concentrate here. So this is, I am giving you the directives that are used in pre-processing. Hash include, we have done. This is used for file inclusion. The syntax is hash include file name. And hash define, this is used for macro. So if there is any set of instructions repeatedly used, then we will give it as a macro. We define it as a macro, and we give some name. And whenever those set of instructions are required, we will call them its name. And these macro calls will be expanded using macro processor. And two types of macros are object like macro and function like macro. Now, this is hash if define, hash if not define, hash if, as else, as else if, as and if. These are all conditional directives. Suppose hash if def add. What is the meaning of this one? If add any macro with name add, if it is defined, then do something. That is the meaning of this one. As if define add means if you have defined a macro with name add, then do something. Okay, I will give you complete code. For this better understanding. As if define add, as else, Look at this one. As if define add means if you define a macro with add, with name add, then I have written this single hash. Single hash stands for nothing, null directive. This is stands for null directive. If you already have defined a macro with name add, then don't do anything. Okay. Otherwise, I can this I could call this add 2, 3 something. I will invoke it. Suppose if you have not defined, if you define, you do this one. If you not define hash else, then hash define add something. This is conditional directives. You are better. You can write better this logical. You are very strong compared to me in logics and everything. So the meaning of this one is if defined. It is used to check whether a macro is defined or not. And if not defined means if not defined. Example here, if means if you have not defined a macro with name add, then do something like this. If defined means it will check for whether it is defined or not. If not defined means it checks for if it is not defined. And as if, you know that if condition, as else, you know this, as else if means else if condition, end if, this is for the end of if statement, as error, it is fatal error. Without anything, just you print error. As undefined, it is used for undefining a defined macro. Already I have given one example. And hash pragma, this is used to call a function before and after the main function. Before and after the main function, hash pragma is used to call a function. Okay, so I have given all the details about all these directives. This is for file inclusion, this is for defining a macro. These are the conditional directives, and these are all conditional directives, and hash pragma is used to call a function before and after main function. Okay, and the main two types of macros are objective like macro and function like macro. This is about pre-processing. So initially the source code will be given to the pre-processing and it will produce the modified source code as output, pure high level language. Then, and one more thing, suppose I have written a program. With name sample, then it will be given extension .c, sample.c, okay, extension will be given to the preprocessor, and the output of the preprocessor will be sample.i, okay, and the output of compiler is target code, that is with the dot extension sample.s, and output will be given by assembler is relocatable machine code, that is sample.o, and link editor, it produces the executable code, that is exe file, sample.e, that is exe. So you can copy this, and first of all take pre-processing. I'll give you some notes. Okay, any doubts you please ask me. Take pre-processing. Take the notes, pre-processing. It takes the source code as input. It takes the source code as input and produces modified source code as output. Produces modified source code as output. Please concentrate on whatever I am saying. So whenever I am dictating, if you are trying to ask or some doubt, then you will typing something, then you will miss whatever I am saying. Ritvik Singh, as define A10, then again without undefining, you are again defining A20. Then okay, after this code it may be replaced with 20. Just you try with this. See, these are the rules only. So some of these you can try with your coding. So you just write the code and you just try it. So some of doubts you can, the system will be clear your doubts. So Ritvik, you are asking that hash define A10. So without undefining A10, again if you define as define A20 after some lines. So after as define A20, the remaining instruction it may give to replace with 20. You just try and tell me. So write a simple code. Okay, take the notes. Take the notes. Preprocessor take the source code as input and produce the modified source code as output. Already I have dictated. Next, continue. If the program is too big, it may be divided into small programs within brackets modules. It may be divided into small programs within brackets modules and will be stored in different files. As define is used for defining a macros. Macro can be a single line statement, that is object like macro, or it can be function like macro also. Okay, Vikas Kumar. Okay, I repeat. If the program is too big, it may be divided into small programs within bracket modules and will be stored in different files. Continue. The preprocessor will take care of all, one second. Some disturbance. Sorry guys. I'll repeat this point. Sorry, extremely sorry. I repeat this point. If the program is too big, it may be divided into small programs within brackets modules and will be stored in different files. I think I have dictated this one. Continue. The preprocessor will take care of all these modules. Okay, full stop. Next line. The commands used in preprocessor are called as preprocessor directives. The commands used in preprocessor are called as preprocessor directives, and they begin with and they begin with symbol hash. They begin with the symbol hash. They begin with the symbol hash. Next. Take list of preprocessor directives. List of some preprocessor directives. Preprocessor directives. Copy all this. Take header file inclusion. Header file inclusion. Header file inclusion. Header file inclusion. Take the syntax. Syntax. Hash include within angular brackets file name. File name. This is example. Hash include standard input output as stdio.h. Header file inclusion. Take the syntax and example this one. I'll give you the notes. Done. Okay, now take the notes. So these are the condition. Okay, I'll repeat. First continue. Okay. Now take file name. File name is included. File name is included in the main program. File name is included in the main program at the specified place. At the specified place. File name is included in the main program at the specified place. Full stop. Continue. Continue. Preprocessor removes all the hash include preprocessor removes all the hash include directives. All the hash include directives by including the files called file inclusion. I repeat, preprocessor removes all the hash include directives by including the files called file inclusion. So wherever you write the hash include some file name at that place, so the code will be for that file name will be included by removing the hash include statement. This is called file inclusion. Okay. Next, take macro. Take the heading macro. Syntax for macro is hash define, and we will give some macro name. Macro hash define. Please write this preprocessor directive. Somebody is asking. Please copy this list of preprocessor directives. Make it fast. Make it fast. I am going very slow. I am dictating slow, even though you are asking bit slow. Take, copied. Next, macro. If a part of program, if part of a program repeated many times, if part of a program repeated many times, then we can define it as a macro. By I repeat, if part of a program is repeated many times, then we can define it as a macro. We can define it as a macro by giving a name to it. We can define it as a macro by giving a name to it. Full stop. Continue. This part is called a macro definition. This part is called a macro definition. Whenever full stop and continue. Whenever that part has to be repeated, it is called by its macro name. Macro name. Continue. These macro calls CALLS will be expanded before compilation. Full stop. I'll give you a break at 8 o'clock. Continue. Macroprocessor is a system software. Which does the job of macro expansion. Macroprocessor is a system software which does the job of macro expansion. source program with macro calls, this is macro processor, this is expanded source program, this is expanded source program. So what I told you, whenever a part is repeated many times, we will define it as a macro, we will give some name to it. So whenever that part has to be repeated, we will call that part by its name. So macro processor will expand before compilation. So macro processor is a software. It takes the source program with macro calls as input and produces expanded source program as the output. Okay, copy that. Okay, actually here we have a problem with this requests. One is saying that our mess will be closes at 8:30. So please give us break now. And somebody will give. Somebody is asking, sir, can you please give break at 8:30? I stay at a hostel and our mess time is 8:30. Okay, so your time starts at 8:30, your mess time, and other person mess will be closed by 8:30. So what shall I do? Huh? Okay, that see, I cannot satisfy both of you. One of you saying that mess will be closed at 8:30, and one of you is saying that, other one is saying that mess will start at 8:30. So I do one thing, I give the break at 8:15. You manage, and 8:15 to 8:30, and even I have the dinner at that 15 minutes of time only. 8:15 to 8:30 every day I fix this. 8:15 to 8:30. Okay, and sorry guys, because many students are here, I cannot satisfy every one of you. One says to go towards east, another one says towards west. So which direction I can go, east or west? So I'll give the break from 8:15 to 8:30. Okay. Okay guys, now types of macros. Types of macro. Object like macro, and function like macro. Object like macro and function like macro. Object like macro, example is this one. Object like macro. And function like macro, example is this one. Okay, object like macro and function like macro. This is as define A10, object like and object like. And see, and repeatedly I am saying this one, today the first class, and this is the theory, completely theory. I cannot go fast, even though dictation is only I am going fast, but the concept I am giving you very slowly. But once I start syntax analysis, the class will be very interesting if you involve to my class. Okay, so don't think that every day the class will be like this. Already I told you, first 3-4 hours only theory. Okay, object like macro and function like macro. This is function like macro. This one. This is the definition. And if you are invocating of macro, add 2, 3, and the result of macro expand will be 5. And you can see one thing, and I'll tell you. Okay, copied? Just copy. I will. Copied? You just write this, and beside this you can take it as example, and write this, and beside this you can take this example. Okay, just look at this, guys. I am defining a macro, function like macro, has define add x comma y. The definition of this one is this one, means the function of this one is this one. So what is the meaning of this? I am calling this macro add made easy. So I am passing the tokens made comma easy, and the result of this macro expansion the result of macro expansion will be this. Okay, as defined add x comma y, x double hash y, and I'm invocating add made easy, add made comma easy, then result of macro expansion will be this made easy. This is the result. So this is used to concatenate the tokens x and y. Made easy, whatever you pass, suppose compiler design, then result will be compiler design as one word. Okay, this is like opposite like macro. And already I told you, and single hash is a null directive. This is null directive and use it to do nothing. Used to do nothing. Okay, single hash, and double hash to concatenate. Okay, guys, dear students, is it clear? So we have done hash include and hash define, that is used for macro. Okay, done. Anything? So just make it fast. Okay, next one. Okay, these are all conditional directives. These are all conditional directives. Hash if define, if not define, hash if, hash else if condition is not cleared, hash else if, okay, multiple conditions, and hash end if to end the if condition, hash error without anything, just fatal error, and hash undefined to define to undefine a defined macro. And so all these, whatever these all in big circle, they are all conditional directives. Conditional directives. Okay. Now take the last one, hash pragma. Hash pragma. It is used to call a function before and after main function. It is used to call a function before and after main function in a C program. In a C program. Okay. Okay, guys. Okay, I'll give you. Shall I give you a break now? Hash error means, see, it's not conditional actually. Even this is also you can say these are the conditional and hash error. So simple. So it is like fatal error. So without anything. And this is undefined. This is undefined means to undefine a defined macro. So I have already told you This is, if I write hash undefined A, means if you have already defined a macro with name A, then it will be undefined. After this statement, whatever you write, and in those statements A will not be expanded with its value. But until before this statement, whatever, wherever A is there, it will be replaced with its value. That is the purpose of this undefined, hash undefined statement. Okay. Now, so that's done. So pre-processing is done, and pre-processor will take the source code and it will produce says modified source code or pure high level language. Then actually pre-processing is optional. Example, the languages which do not support hash include, then they do not require pre-processing. Are you following? So pre-processor to allow the user to use the macros, to use the header files, okay, and it is an optional. Example, the languages which do not support hash include, they do not require pre-processing. Okay. Next, compilation. Compiler takes the modifier source code as input and produce the target code as output. Already we have seen about compiler, and our main subject is compiler. We will see lot about this compiler after this. Okay. And compilation is also an optional. That means it is not necessary for every language. Example, HTML. Every language do not require compilation. And script language, JavaScript, they do not require compilation. Okay. So take, and somebody is asking the differences between the macro and function. Yes, I will dictate, but better to dictate I will write on the board. So once you come after the break, you can copy, because if I am dictating, you are taking so much of time. So I write on the board and I will show you. Sometime I will display and you can copy from it. Okay. Now pre-processing, take a note. Pre-processing is an optional. Take a note. Pre-processing is an optional. Example, the languages which do not support, write this one, which do not support hash include, they do not require pre-processing. Okay. The languages which do not support hash include, they do not require pre-processing. Done. Next, compiler. So pre-processor is done. This is done. Okay. Now take the compiler. So I need not to say it takes the modifier source code as input and produce the target code as output. Already we have done. I have given the notes also. Okay. Now take note. Compilation is also an optional. Example, HTML, JavaScript, they do not require compilation. Okay. And I hope you have copied this one also. If you write a program, if you save that program, it will be saved with the extension sample.c. The output of preprocessor is sample.i. The output of compiler is sample.s. The output of assembler is sample.o and sample.exe, that is E. Okay. Done. Okay. Now, so compilation is done. Now go for assembler. Take the heading assembler. Assembler. Just 2 minutes. I will give you the break. 2 minutes. Assembler. It takes the assembly language code as input. It takes the assembly language code as input. It takes the assembly language code as input and produces relocatable machine code as output. Relocatable machine code as output. Which has to be loaded in main memory, which is ready for execution. Okay. So until now we have completed. So after the break, I'll give you the definition, the differences between macros and function. Then I will start with the linkator and loader. Okay. Guys, just you take the break and come after 15 minutes. Come after 15 minutes. My time is, it is 8. Okay, I'll see the yeah, it is 8:15. So come at 8:30. Thank you.